All right. Again, welcome. Good morning, everyone. Thank you for joining us. My name is Kayla Snyder. I am the Senior Programs Manager at the Michigan Green Building Collaborative, formerly known as the U.S. Green Building Council of West Michigan. We have recently rebranded to better reflect our shift from a regional to a statewide focus with the same mission. And today you are on our first MassTimber webinar series, if you will, in collaboration with MassTimber at MSU. So all 4 webinars that we have scheduled are in collaboration with MassTimber at MSU. So you will be seeing a lot of both Sandra and myself. But today we are talking about MSU's STEM teaching and learning facility, which is a dynamic learning laboratory leveraged by MassTimber at MSU. This project offers valuable insights and inspiration for anyone interested in building a MassTimber project in Michigan and beyond Michigan. So before we dive into the introduction of the panelists and the content in today's webinar, I just have a couple of announcements for everyone. The webinar is being recorded, and the slides and the recording will both be shared with everyone who registered after the webinar. So there will be a follow-up email, and you will have access to both the slides and the recording link. And then if you have questions throughout the webinar, you can go ahead and utilize both the chat or the Q&A feature at the bottom of your screen. So before we dive in, I just want to tell you about our future events. The 3 other MassTimber webinar series educational events will be listed in here. But before that, we have another Lansing 2030 District webinar coming up on March 27th from 10 to 11 a.m. via Zoom. This is about incentives, rebates, and funding opportunities for efficiency projects. And this is part of our emerging Lansing 2030 district. So you will hear from Consumers Energy, Eagle, the Lansing Board of Water and Light, Michigan Saves, and PACE. So I guess even if you're not in Lansing, it's a key webinar to kind of understand what funding is available. But yes, we are doing that through our emerging Lansing 2030 district. Our next MassTimber webinar is tentatively scheduled for April 24th from 10 to 11 a.m. via Zoom. They should all be on Thursdays, like later in the month is what we were aiming for. The other 2 will be in June and July. But we are just wrapping this up with our panelists, confirming the date, and the registration links will be available for the rest of the MassTimber webinars soon. Our next in-person event is the Michigan Energy Summit. If you have never been, it is an all-day conference focused on energy efficiency, and that is on Thursday, May 8th from 8:30 a.m. to 4:30 p.m. at the JW Marriott in Grand Rapids. This is where we have breakout sessions, keynote speakers, there's a lunch and a happy hour, and we also award our biggest losers in the Michigan Battle of the Buildings competition. And then the 2 other MassTimber webinars will be on the DNR Newberry building and Adelaide Point condos. And again, that will be in June and July. All right. And with this, we consider all of you to become, we encourage all of you to consider becoming a member of the Michigan Green Building Collaborative. As a member, you'll support our mission and gain access to exclusive resources, networking opportunities, and ongoing educational events. We invite you to join this growing community dedicated to advancing sustainable building practices across the state. So we really like to talk about all things building science. This is very evident, with our talk about energy efficiency at the Michigan Energy Summit and MassTimber here today. So you can either scan the QR code here, or I think Wendy will be putting some links in the chat. We also want to give a huge thank you to all of our sponsors and supporters, and a heartfelt thank you to our visionary supporters without whom we would not be here today. DTE, Consumers Energy, Eagle, and the Wege Foundation. So with that, I would like to turn it over to Sandra Lupian, Director of MassTimber at MSU, And before I actually hand the mic off, I forgot to mention that we had Sandra speak at our annual Party and Leadership Awards ceremony in December. And that is how this webinar series was kind of brought about. So I'm really excited to have her talk a little bit, or, invite all of these panelists to talk about projects in deeper detail, because we got a very high level overview at the annual party, and that is recorded if you ever want to go back and look at it at our YouTube channel. So with that, I will turn it over to Sandra.
Great. Thank you so much, Kayla. Hello, everybody. Thank you for being here. I just want to start by expressing my gratitude to Kayla and the Michigan Green Building Collaborative for inviting us to collaborate on this MassTimber series. I'm really excited that my GBC's involvement I think it's really opening doors to new MassTimber information for some new to us audiences. So I'm seeing just now in the chat a lot of folks who are new to us, but some old friends as well. And I think that's wonderful. And for everyone, I just want to invite you, if you're not already plugged into MassTimber at MSU's resources, to connect with me after the conversation so we can get you plugged into some of the stuff we're doing and offering. I'm so excited for this conversation today about the Michigan State University STEM Teaching and Learning Facility. This is one of the first MassTimber buildings in the state, and I think I can safely argue still the most prominent one. I think we have competition on the way, which is great. Our panelists today, Dr. George Berghorn, architect Kevin Marshall, general contractor Bill Bofeisel, and Andy Reese, who represents the installer on that project, will later walk you through kind of the why, the how, and the lessons learned in creating this beautiful, amazing building on our campus. But first, I'm going to go ahead and share my screen and offer a brief overview of MassTimber at MSU, what we're doing to advance MassTimber in Michigan, and then a little bit, just a quick intro to what MassTimber is, because I think while some folks on the call are very well versed, there might be some for whom this is new, and that's actually really important. We want new people coming to the table to be thinking about MassTimber. So our program, MassTimber at MSU, it's a collaboration inside the College of Agriculture and Natural Resources across the Department of Forestry, the School of Planning, Design, and Construction, and MSU Extension. And we work to advance MassTimber construction and production in Michigan, the Great Lakes region, and beyond, which is what Kayla did just say. And so I'm repeating it because everybody needs to hear things more than once to kind of get them. But we do that really by doing all the things that MSU as a land-grant university does, right? Research, teaching, and extension. And that extension really covers stakeholder engagement and outreach, communications, and even thinking about policies to advance MassTimber. Importantly, we work in very close collaboration and with funding support from the Michigan Department of Natural Resources, Office of Public Lands, and have funding support from some other public agencies as well. So MassTimber, I always start out by explaining what it is, just so we're all like, to basically level set, right? Even if people know it, it's important for us to all know kind of how we're referring to it and what we mean. So when I say MassTimber, I'm using an umbrella term for a variety of really big engineered wood construction materials that we're excited to use in large buildings and commercial construction, multifamily, tall buildings, in ways that we have not been able to use wood structurally in the past, right? So really using wood in new ways to build more sustainably, oftentimes more efficiently, and I think easy to argue more beautifully in many cases. A few different types. We've got glue laminated timber. Those are columns and beams. You've seen those before. Cross-laminated timber is really the type of MassTimber responsible for the coining of the term MassTimber. These are gigantic panels made by putting together layers of dimensional lumber such that each layer is in the opposite direction of the one next to it, to create something that's really, really strong and can be used in multiple structural applications. Mass plywood panels, nail laminated timber, dowel laminated timber, laminated veneer lumber, all different types of MassTimber with different applications. The two that are most common and most in use right now are glue laminated timber and cross-laminated timber, and those are the materials used in our STEM teaching and learning facility. A few things that MassTimber at MSU is doing to foster a MassTimber ecosystem in Michigan. First, I think George is going to talk more about this. We really leverage our STEM facility as a learning laboratory to create knowledge and community across the state. We host a quarterly virtual MassTimber community of practice. It's an online space where people can come together to learn about MassTimber, to exchange information about MassTimber with other people who are engaged or seeking to engage with MassTimber in Michigan. This next meeting is actually next week, March 19th, and we're going to be talking about the MassTimber elements of the new 2021 Michigan Building Code. So if you're interested in that, follow up with me and we can get you some information. We bring people together, we host events, we take people to events. We want to make sure that people have access to information and access to each other to build networks and partnerships. For example, later this month, we've organized a delegation of Michigan folks to attend the International MassTimber Conference in Portland, Oregon. Again, if you're interested, let me know. And then research and teaching. We have a diverse research portfolio related to MassTimber across forestry, forest economics, chemical engineering, construction management, structural engineering, all different types of research, and then also work developing curriculum to educate students and professionals about how to build with MassTimber, how to design MassTimber, really working to increase the knowledge base to advance this new way of building. Importantly, there's been a lot of momentum growing around MassTimber in Michigan. We now have more than 60 projects that have been completed or are in the pipeline statewide, all different types of buildings, You can see some of them listed there. So it really spans from like single family homes all the way to like an 8 or 9 story apartment building and kind of everything in between that, in cities, in suburbs, and in small towns. So what I like to say is that I think people everywhere are seeing something for themselves in MassTimber and they're taking action, and that's very exciting. Okay, that's where I stop and start leading into others, but if you want to plug in with what we're doing, please kind of take a picture of the screen and follow up with me and we'll get you connected. But it's now my great pleasure to move to the substance of the conversation, right? And start really thinking about how the STEM facility came to be, the how, the why, the lessons learned, all the good stuff that you're here to say or to learn about. So the first person who's going to speak is my colleague, Dr. George Berghorn from MSU. He's an assistant professor of construction management and serves as the research director of MassTimber at MSU. And he's really going to start with kind of that why did we do this and how did it come to be a MassTimber project?
Thanks, Sandra, and good morning, everyone. Like Sandra said, my name is George Berghorn. I'm a faculty member in the construction management program, and I'm the research director for the MassTimber at MSU program. And relevant to this conversation today, I've been involved with MassTimber related efforts at MSU since 2016, so almost for the past 9 years. So what I'm going to share with you this morning is just a little bit of the history of how the STEM building came to be at MSU, and then how we were able to effectively make the case for a first of its kind MassTimber structure on campus within the state back at the time that the planning process was being conducted, and now how the building continues to build that case for MassTimber construction statewide, regionally, and nationally. So every good project needs an origin story, and this is ours. So in the summer of 2016, there were a group of individuals from Michigan who convened in Madison, Wisconsin at the U.S. Forest Service Forest Products Lab. These were primarily academic folks from universities across the state of Michigan that decided to get together just to better understand what kind of research support and capabilities were available from the Forest Products Lab. Through those meetings and discussions, though, one of the things that the group really settled on was, in order to propel MassTimber interest forward in Michigan and really to move it out from just sort of a niche interest type of thing into broader adoption, we agreed that some university within the state should really take on the mantle of trying to get a MassTimber building constructed on campus. And that was for a variety of strategic reasons. Obviously, with public universities in the room, these buildings would then become publicly accessible to others in the community, both professionals and also people within the community who might just be interested in mass timber. But also importantly, at least for MSU, U of M, and I believe Wayne State University, we have written into law that the boards of trustees of those universities are in effect the AHJs for building projects on campus. So not to say that, you know, anyone thought we should try to supplant or circumvent what local planning and building offices were doing. But our concern was at that time in 2016, there wasn't enough local knowledge of what was possible with mass timber. So we thought building a large facility on a university campus would really help eliminate a lot of concerns and questions that might come along from a local building office review. In February of 2017, a group of faculty plus the forestry department chair at MSU met with our executive VP, and I was part of that meeting, so I can speak firsthand what happened during that meeting. But in essence, the four of us laid out the case for why MSU should consider an upcoming building project as to be a mass timber building, and I'll talk about that on the next slide when I talk about how that original case was made. But I think there were certain things that were, again, advantageous to us at the time, namely that the executive VP of the university in winter of 2017, that individual had previously served as the dean of the College of Engineering. So he was an engineer. He understood the interest in having campus get used as a learning laboratory. Frankly, you know, like probably all of us on the call, he was a little bit of a building nerd. So sharing this idea of new building materials, new techniques, new technology with him was something that really resonated, and he moved that message forward to the president of the university. From that point forward, though, for about the next year and a half, I term that as our long and winding road period, because we went through some fits and starts as a university during that period. We went from the executive VP conveying great enthusiasm to the president to then maybe looking at backing down from a full mass timber building. And there were a lot of reasons during that time, but what it really boiled down to was, again, this was something new. This was something that had not really been done in Michigan, especially at this scale. And so there were a lot of uncertainties: cost uncertainty, schedule uncertainty, material availability uncertainty. And those uncertainties really plagued some of the decision-making process. So I think the lesson learned during this time was we had this faculty advocacy group, and we continued to press the message and really focus on what the benefits of having this building on campus would be. Well, lo and behold, by the time we got to the end of summer of 18 in August, we did have a groundbreaking. We had a groundbreaking for the STEM teaching and learning facility as a mass timber structure. As the other panelists will talk about today, it ended up as a mass timber hybrid structure, but still a significant mass timber component of this building. And then moving forward 3 years, we had our opening in summer of 2021, which of course was delayed a little bit due to COVID taking place during that time. Excuse me for just a moment. So at the time that we were meeting with all of these individuals on campus to make the case for this building, we really had three key messages that we were putting forward to make the case. Of course, the first was that this was significant innovation. This was a first of its type building in Michigan, again, due to the scale and the construction type. But it also ended up being a first of its type building as a laboratory facility. Now, granted, this is a teaching laboratory, it's not an analytical laboratory, but there are of course, concerns with construction typology, especially as it relates to vibration control and isolation of spaces. So there was a lot of learning and a lot of really great demonstration of innovation that would be possible through this building. Again, I mentioned we spoke with our executive VP about this concept of campus as a learning laboratory. he was very vocal at that time that any new structures that are built on campus should themselves be used to engage students in learning about related topics. So this was, for us, it was a very easy selling point to our upper administration of the university, but it was something that continued to be messaged through conceptual design, through pre-construction, through construction, and now post-occupancy. But we've changed some of our ideas of what that looked like from back in 2017 to sort of post-opening and even now how we use the building as a resource. And then a really big part of the case was that a significant portion of this project, I believe it was about a third of the project, was being funded through capital outlay from the state of Michigan. And there was a significant interest from individuals in the legislature involved with the capital outlay process to really propel innovation forward. There was the chair of the Michigan Senate Higher Ed Appropriations Committee came from a strong forest products district at that time. So he had some really key interest around some demonstration of some modern forest products technology. So again, I think there were a lot of things where the timing was just right, and we were able to leverage some of that good timing, but it was leveraged through strong messaging around these 3 points. And ultimately, that's what got us through that long and winding road period all the way to delivery of a mass timber structure. But if we look at the building now, the case for the building now has launched from those 3 points and really grown into something far more robust than, I think we could envision it back in 2017, but I don't think we could envision exactly how it would have played out. So, we went from talking about innovation as sort of a hypothetical in 2017 to now it's really innovation on display. We've received significant national recognition through awards, through publications. There's been more focus on the building as a laboratory, so kind of getting back into that lab use. We've been consulted, the project team has been consulted numerous times by project teams that are doing other similar type projects around the country. So, now it's really a case for the university to say, we're advancing parts of our land grant mission, especially that outreach, an extension part of our land grant mission, through this innovation that we're able to so clearly put on display through the physical embodiment of the building. The building has really become a teaching tool, but maybe not in ways we initially thought. So we've done some work to create some virtual environments around the building, and we're able to share that virtually. I've got a couple of students right now that are working on much more interactive virtual environments that are built from the building. And we're using some of those virtual environments as a launching point to launch some national model curriculum that we've been developing over the past couple of years. The thing that I think really, I don't know if surprised is the right word, but really took us was how powerful the building became as an outreach and engagement tool. And this, again, continues to be a case that we can make on a regular basis with our administration. Sandra and I and a few others that have been trained on tours in the building, actually all 3 of my co-presenters today, we've taken at least 3,500 people through the building. And these are largely AEC community members, but also some local officials, some state government officials, non-governmental organization officials, and folks from other countries, from universities and trade organizations from other countries, to really better understand what we did in this building, what might be possible for them. Sandra showed you the map with the 60 plus projects that are somewhere in the pipeline in Michigan. And, we always talk about the fact that if you look at those 3,500 plus tour participants, the vast majority of those projects have someone on their project team who has been on one of these tours through the building. We've also been able to leverage the building and these tours to provide technical assistance to project teams. So sometimes that comes directly from us at MSU. Sometimes it's been MSU connecting people with organizations outside of MSU to help provide that technical assistance. But again, really using the building as a center point, as a centroid for this level of support. And then fundamentally, what the building has become, and the real case that we can make with our administration now, is that the building has become a conversation changer. We've changed the conversation, at least in Michigan, from this is so new, this is so complicated, we're not really sure where to jump in to a mass timber project, to now, oh, okay, this is possible. This is very doable. We often joke that as we bring people through the building, oftentimes, one of the realizations is, yeah, this really isn't rocket science. It's not as difficult as maybe it seems like it is when we're starting at the ground level, kind of looking up at the top of the mountain, so to speak. So the building's use as a conversation changer is critical, because part of what that's been able to do is it's been able to allow us to engage in research work like a supply and demand study for mass timber regionally, which has the end goal of being leveraged to help industry members decide if they wish to either relocate or bring a manufacturing facility or facilities to the state of Michigan. Again, the building itself becomes that conversation changer, because as people enter the space, as they come into it, they start to understand why a mass timber building is so unique and so important, and why the reaction that people have to these structures is what it is. So our goal now is to use that building to really build out the ecosystem, the economic ecosystem for mass timber within Michigan and within the region. But it all starts again in that centroid, which is the MSU STEM teaching and learning facility. So thank you very much. I will stop my share.
Great. Thanks so much, George. Great to see you. Great to hear from you. So fun to hear that kind of origin story of the building again. After, giving so many tours and thinking about it all the time, but it's always good to look back at the history. So Kevin, hopefully you can get your slides up here while I'm introducing you. So now you're going to get to see a lot of beautiful pictures of the building, which is probably partially what you've been waiting for here, and hear from Kevin Marshall, who is the lead architect on the MassTimber, the STEM teaching and learning facility at MSU. He's with IDS, Integrated Design Solutions, based in Troy. And Kevin, please take it away.
Good morning, everyone. Glad to be here presenting once again on this wonderful project. I've got a pile of slides to run through, so I'm going to go kind of rapidly. The building is broken up into essentially 3 buildings, with the core of it being the Shaw Lane power plant, and then the STEM wings, and then the classroom. Well, the classroom addition is actually part of the power plant code-wise, but it's these 3 chunks that make up the building. The Shaw Lane power plant was a coal-fired power plant that was decommissioned in 1976 and sat waiting for its future use ever since. When we added to the project, our site was chosen, and was chosen by the university in part to engage as a learning center with the power plant and create this whole facility, this complex of buildings. And then later on, towards the end of the project, the classroom addition was added, such that we created a lecture hall and some large flat floor classroom on the upper floor that is serving a significant need on campus. So I'm going to talk a little bit about the lessons learned, and we'll start off with mass timber design considerations of structural design. And there was construction type, fire resistance and panel thickness, vibration analysis, which George mentioned, and then right sizing of the timber. From a construction type, when we started this out, this was pre the 2021 IBC, and so types A, B, and C of a type 4 construction did not exist. So we were relegated as a business occupancy in a multi-story building to either being type 3A or B or type heavy timber or type 5B. And so we worked with the state of Michigan, with the Bureau of Fire Services, and determined that the building best fit not a type 4 heavy timber, but actually type 3B, because of the need for, from the laboratory's perspective, to have some concealed spaces within the building, which are generally not permitted in a heavy timber building. And then we could have, as you can see on the lower left, the south stem being the biggest chunk of the building at 24,000 square feet, could have technically fit within type 5B, but we wanted to leave some room for, since we were going to build it at type 3 capacity anyway, wanted to leave the university with some ability to either add on or renovate or do things in the future with the project. When we jump into fire resistance and panel thickness, the building has a type 3B as 0-hour fire rating for the structure, but there are still elements that need to carry fire rating, such as the stair shafts. We used a CLT panels to help stiffen the building and also carry some of the load of the stairs. And our structural load required 5 layers, a 5-lam CLT for the structural capacity. But then when we calculated what we needed for the fire rating, it added 2 layers. So we ended up with, in the top center section, you can see the vertical joints, how they're handled from this panel with a 7-ply CLT wall system. And then the bottom shows a typical edge bearing on a CLT wall. This is how we first approached the project. But then we discovered that as part of the Michigan Building Code, you have to support the rated construction all the way down to grade, and to tie in our non-rated floor systems into the wall as shown on the screen would not have been possible. So we actually hung the CLT floor decks from the side of the panels, as opposed to embedding them in, as we see on this screen. Then we jump into design considerations. And the first one that we'll jump into is beam connections. There's a myriad. When you start the process of a mass timber building, there's a whole kit of parts that you can use to choose from in order to construct your building. And part of that will be based on your construction type and if you need to have protection of your connections for the primary structural frame system, in which case you would use the bottom center image, which has or you have to wrap them in gypsum board or some non-combustible surface. The STEM project, because it was type 3 and non-rated structure, we were able to expose the connection points, and that helped with tying in with the steel structure that was inside the power plant that was adjacent to it, to create some synergies between the two buildings. And then the other images just show some different methods for connecting, how different things that can be assembled to make these connections. And then there's the column design, where the columns started at grade and the top right image with a large base plate that extended down to the structural foundation, and then the floor was poured around it. And then you can see there are, in that upper right picture, there are 10 dowels that run through a knife plate, which you see in the top center picture, that tie the columns to these base plates. One of the things we learned during the process is every manufacturer has kind of different ways they like to do connections, and it's one of the most important things that we weren't able to go into, which was to select your mass timber provider early in the construction process or design process even, so that you can right size the timber structure to their typical modules and work with how they like to make connections. And then all buildings have a lateral system that keeps the building rigid from wind and movement. And we had to choose a decision on how we wanted that. We could have done a timber, as you see, which is the University of Massachusetts in Amherst building that we went and toured. They used glulam beams for their diagonal bracing. The stem project, we wanted to keep it lighter and a little thinner and also bring more steel elements into to tie in with the power plant. So we use the steel diagonal bars, as you see in the lower right, and then there's the knife plates in the upper left that occur at all of these diagonal brace locations that tie the whole structure together. And then here's some more considerations on how the transitions happen, different options for consider construction and making your transition as the columns stack as they work up the building. Now we'll start a little kind of a typical erection sequence we start with the ground floor columns and your beams and your transition to the next story. And that's evidenced in this slide. And you can see because of structural loading on the STEM project from the south, in the south penthouse, we inserted 4 steel columns within the steel frame or within the wood, primarily wood frame, because otherwise the columns would have gotten so large if they had been timber that it would have affected program within the labs in the teaching floor. So we kind of used, as George mentioned, a hybrid structure to create this. Then we bring our CLT panels in, and then the next columns for the next floor. And at this point, the floors are tied together and stable. And I think George will talk about as part of a schedule, not George, but Bill will talk as part of a schedule, the ability to work underneath that floor as it went up, which opened up, which had some benefits in that. And then you've kind of finished it off with your decorative pieces, the edges of slabs, in our case, we had a 3-inch concrete topping, and then the railing system that went on for our 3-story opening at North Stem and South Stem. And now I'm just going to jump through a few pictures of the completed project just to kind of whet your appetite. And then I think I hit my target almost.
Well done. It's a beautiful building. Wonderful. Thank you so much, Kevin. Wonderful to hear a bit about the design, what went into the design, the considerations, and a little bit about how the strategy for putting the building together. So thank you so much for sharing that. Bill, while you're getting your slides up and ready, I'll introduce you, Bill Bofeisel. He's the project director for Granger Construction based here in Lansing. And he was Granger was the construction manager on the STEM teaching and learning facility. Bill led that team and is ready to talk with you about how that looked and what they learned. Thanks, Bill.
Thanks, Sandra. Bill Bofeisel, Granger Construction. Been with Granger a little over 19 years. This was an exciting project to be a team member on. For obviously what you're hearing from all the other team members here, there was a lot that went into this project. To maybe pull on the string a little bit of what George was talking about and what Kevin talked about is that there was that early investigation about what mass timber means in construction, especially in Michigan. And so starting back with what George talked about of going to Wisconsin and having these discussions within MSU, we needed to, as we got closer to the project and we were challenged with understanding what mass timber construction looked like for this project, we set off and developed a document that was choosing by advantages. And so by doing this, we kind of set the background up of understanding what our challenge was for this project and how we could convey this information with a conclusion at the end to understand whether mass timber was something that we wanted to move forward with. So we set up a study team early on within MSU, the design team, then the constructors. We brought in some subject matter experts to help this team, obviously, because for this collective team, this was the first of its kind for all of us to be working on mass timber. So we wanted to get some industry experts as a part of this panel. And then we started to develop a series of workshops. In the latter part of December, we we wanted to develop this matrix and do a comparison between steel and mass timber and understand the advantages, disadvantages, and walk away with a message from that. Then we could then take that into a second workshop where we brought in more of our partners within MSU to let them understand our findings and let them ask questions and maybe understand some follow-up that may be needed. One of which was an interesting point where humidity was a question from the team and the partners there. So we took that forward and tried to understand that more, and we did throughout the project. And then lastly was structurally looking at it. You know, heard George talk about, you know, maybe some of the considerations that you need to evaluate when it comes to vibration or other building type uses. So we got into some technical discussions on the structural part of the building there, and decided, you know, how does this building react to the envelope and all the other interfacing parts and pieces that comprise of a large commercial building. So in the end, some of our conclusions, there was no reason why we couldn't do mass timber. And so the team was excited, and to kind of cap that off, we wanted to go see an existing mass timber project. So you heard that we took a field trip out to UMass Amherst, and I think from that, everybody was energized and ready to hit the ground running to do all things mass timber. So with that, you know, we as Kevin and George kind of talked through, everybody got through that programming phase, right? I look at a project in 4 big buckets. And we got through that programming phase, and we're kind of leading into that schematic design. And as you saw, Kevin, with the layout there, we started to understand what that base sizing looks like and what the spatial relationships are between the different departments of the project. So as we got there and we started to understand what the bones of the structure was going to look like, we knew after doing a bunch of outreach that this was the right time to bring on a mass timber partner. As Kevin mentioned, there's a lot of, you know, it's not a typical commodity like steel is, or even a concrete structure. These are, you know, somewhat customized based on the manufacturer that you choose to work with, from a timber manufacturing process and even through a connection design process. So bringing those partners on board early was a large part of the success of this project. And I think that goes to say for any project, the sooner that you can bring your team on early and help influence the design and provide that level of collaboration, your project's going to be successful. And then from that point forward, we used their insights and their expertise, Nordic in our instance, which was interesting enough, is that the project that we went to go look at UMass Amherst was actually a Nordic product itself. But you know, understanding, you know, how to right size, you know, Kevin mentioned the right sizing of the timber. You know, we made that transition early, and align that with the architectural elements as well with the building. So we were able to move forward hand in hand with our supplier to provide a product that was cost effective and maximized the overall project there. Some things too outside of that is, you know, in design development, you want to be able to think about your wood sourcing requirements. You know, where are you going to get it from? What's it going to look like? What kind of species? There are options, you know, if you're North American or European from supplier standpoints, everybody's going to have that right sizing element, and understanding, you know, those delegated design elements there when it comes to connection design or other parts of the project. To maybe pull on that a little bit farther is that, you know, when you get to steel, it's pretty easy. You work with steel subcontractor and everybody just starts doing their calculations, and the building's kind of already been designed. You just got to follow the calcs and some shop drawings. Whereas mass timber, it's a little bit different. You want to early on board your partners, but it's not just a local sourcing at this point. Hopefully in the near future, we can get a little better and we have more local resources. I think that's part of the end goal, but just as an idea of what this map looks like and what your sourcing options are, is this is a national search or even international search as well. So understanding, who you can talk to and what products they provide is going to be an important part early on when you're starting to develop your project. Some people are vertically integrated and can do everything, and some people only supply one piece of the puzzle. So understanding how you can source this is a critical part of your success of a job. Mentioned early on, right? You got to have that collaboration. This isn't just a design bid build process with MassTimber. You need that influence early on from your suppliers so that you can take advantage of, efficiency of your frame, your connection designs. You're really doing all these things up front to be a good steward of the owner's money. And also the indirects of that will be is the early coordination. You get to bring on your MEP and potentially your facade folks, depending on how vertical you're going. If you're over 4 stories, you get into that BIM collaboration process early on, and you can prefabricate your vertical openings or any openings that you have within the MassTimber. So again, you're just being more efficient with your pre-manufactured timber. To then, once you start to do the install in the field, as Kevin alluded to, is that you can have that handoff faster with your interfacing trade partners. So any of the overhead mechanical, electrical rough-in can go in earlier than you would with a typical steel and concrete slab building. This system for MassTimber plumbs and racks itself as you go up. So that allows that compression and schedule if you're able to take advantage of those front end loaded task early on within the project. And to that point is the front end of working with MassTimber. It is a longer pre-construction process. You need to approve the geometry. You need to get through some of the connection design, and then allow them to start milling some of the rough pieces and get that programming in CNC initiated. So an indirect part of onboarding a MassTimber partner early on is dealing with this early heavy front loaded pre-construction process and this collaboration that you do, but you're also in the back end, you're trying to predict and manage your production slot for fabrication as well. So there's a lot of things going on there. Other challenges, as you become more familiar with MassTimber, I don't know if these become challenges. They're just part of the process. It's a non-traditional procurement. So just being aware of that, and your search is more national, could be international. The tolerances, if you're working around existing buildings, is a lot different than steel. The tolerances we have with this project, and I'd say probably is common for most, and Andrew can talk to that a little bit, is we are at 1/16 of an inch with our tolerances there. So being adjacent to an existing building was critical, understanding what the tolerances would be, and then also understanding how to protect your finishes while you're constructing and during the life of the project before turnover is an important element of the job. And then education in general, I think we're all getting better now with webinars like this or going out to the MassTimber conferences. The more people that we can educate about how to work with MassTimber, the more successful everybody's going to be, even just the municipalities as well too. So it's going to be critical as we move forward with MassTimber. Advantages, right? The total team collaboration. I love IPD, design assist, getting everybody up front and getting a team early on. I think that initially drives success. So that's a big advantage of MassTimber. Prefabrication, right? Smaller crew sizes. You're fabricating offsite and delivering it, especially when you have tight sites. You're picking it directly from a trailer bed. One time, minimal laydowns needed, and you can get in there faster and start installing your overhead utilities or whatnot that may attach to the mass timber there. And then obviously the beauty of the timber is a huge advantage. And having that level of exposure, I think, was awesome for this project, as Kevin mentioned. It really was able to show off the natural beauty of the timber and all the utilities that go into play with these lab buildings here. So I think that's all I have at this moment.
Excellent. Thanks so much, Bill. Wonderful insights. Hopefully folks found that helpful. I think there's a question typed into the Q&A for you if you want to go in there and answer it. In the meantime, we're going to pull up Andy Reese's slides. Andy is with Christman Constructors, which was the mass timber installer for the STEM facility. He's the director of pre-construction and mass timber at Christman Constructors. So Andy, with that, I'm going to say one more thing before you take it away, which is that it looks like we will be going a few minutes past the start of the hour. So hopefully you all can hang in there with us. And in case you have any questions, we want to be sure to accommodate them. All right, Andy, go ahead.
Yep, thanks for inviting me. Like I said, I'm Andy Reese with Christman. This project here was Christman's first first project in mass timber. And management back in 2017 saw that mass timber was a new product coming along that was replacing, like you see on the screen, construction like this, replacing concrete structures. Christman has been big in the concrete industry for many years, and it was kind of a threat to have something new coming in and replacing something that we do. So management made the decision to investigate mass timber and see if there was something that fit our company. When that happened, we started investigating mass timber. We attended the Mass Timber Convention in Portland, started reading articles, started looking into it. So when the MSU job came down, Bill and his team asked us to quote it. We were very interested. One, because it was something new for our business. It's a local job, and Christman has been working at Michigan State for 110 years. So it's a very important job for us. So next page, please. So one of the major questions we had to ask is how is this done? We've got a lot of professionals here with a lot of experience, but we're working with something new. New product, goes together like steel, but it has its different challenges and its different connections. Like it was mentioned before, there's lots of different ways these connect. They vary from manufacturers. So trying to learn all this interesting and different ways of doing things was a challenge. So we got together and we figured out, what questions we need to ask. How does this go together? How does it need to be handled? It is a finished product. What crews are we going to need? How many guys? What kind of experience do they need to help, transfer into this type of construction? What tools are going to be needed? There's lots of long screws that have to be driven in. Everyone's really amazed when you show them some of these, 2-foot long screws that are used to construct these. Another item is, what are the safety requirements? We're vertical. We have a history of doing vertical construction here at Christman, so we had some ideas, but how were we going to move around the site? How we're going to keep our guys safe? How we're going to shore the building so it's safe? Equipment that's needed. You can see some basic cranes here. A lot of this stuff is pulled from our tradition and what we've done before, and we've adapted it to mass timber. There's also a lot of unique tasks on this job that we had to look into on some of the connections and dealing with the timber. We also had to look at productivities. How long does it take to put this together? How long does it take to do the connections, finish everything up? So we took our knowledge, answered all these questions, but the overall writing thing there is we came up with everything, and at the time with this project everything was unproven. So we started the first job. We had an idea what we wanted to do. We had a plan. We had to go out there and prove that we were right. So that was probably the biggest challenge on this. Next slide, please. So during the project planning was probably one of the most important, working with Granger and Nordic, who had all the experience on doing these types of buildings. We planned the project like normal, schedule these deliveries, site logistics, but then we started adapting to work with the mass timber. You can see here, everything is on the ground, it's wrapped. You got to keep it clean. You got to not damage it by sitting on the ground, somebody running into it. So that was one of the things we had to learn, teach the guys and be nice with the material. As Bill explained earlier, all deliveries were coming from Quebec on this project from Nordic. That is a 2-day drive. It's not like a steel fabricator, something wrong, you go 15 miles away, get it taken care of. Nordic did a great job bringing everything out, organized, so we could erect it in order. But during this planning, we just adapted all of our skills and converted them over to MassTimber to kind of develop our program here. Also in the project planning, there was items that we had normally never done, like the base plates. That was something we had to learn. Putting up the bracing that was used on this project, which was heavy and very expensive. Next structure, or next slide, please. And then just dealing with the existing building. We had the 2 wings on this, the north and the south, but what we also had was some CLT floor inside of the building on structural steel. So some unique challenges there, trying to get those panels inside with a visual side down without damaging and scraping them. The hybrid structure, working with getting some steel in, that was something a little new for us, and some union challenges there. Like I said, that the bracing and erecting pieces in the side was a definite challenge. And then the tolerances, as Bill spoke to, and that has been probably one of our greatest lessons learned. Attaching mass timber to concrete, attaching it to masonry, everything's different, and the mass timber is very precise, and that's where a lot of our challenges came up on this project and projects after. So that was probably the greatest lesson learned there.
Great, Andy. Thank you so much for that. So we are going to make time for some questions if you have them. So you can feel free to either type them into the Q&A or type them into the chat, whatever you're more comfortable with, and Kayla will help make sure that we're tracking those. But I have a couple that I've already seen and pulled from the Q&A. So the first one, I think, Bill, is a question for you. Pete Cobalt was asking about builder's insurance and property insurance for this project. And I know that obviously you have a lot of insights about the builder's insurance. So could you speak to that a little bit? Was it different than it would have been had it been a steel and concrete project?
Short answer is yes. And so obviously, given when this construction began, this was very new to everybody in the region. So yes, we did pay a premium in regards to builder's risk and insurance on that front. There has been a lot of work done since then with insurance carriers to understand how to insure mass timber. A lot of people back then were just looking at it as a traditional stick-built house. And so they didn't understand what the replacement value would be if damage was made to the mass timber. But over the years here, I think there's been a lot of education. I guess going back, pulling that string on education, is educating everybody so that these premiums do come back down in line with typical steel construction, which I think they are. But yes, there was a premium that we had to pay. But I think the insurance industry, they are always at these conferences now, and they're a voice there. So, and I think obviously with some of the more recent flame spread and vibration tests that have been happening out west are providing a lot of valuable insight to these insurance industries to better ensure the construction during and post-construction.
I think that's really helpful. And I think, Woodworks has been taking the lead on helping to educate the insurance industry and being proactive about strategizing and also providing education to people like you who are working on these mass timber projects and wanting to think about how do I approach the insurer about mass timber so that I get a fair premium. So it's in progress, but I think it's fair to say that you'll still encounter a premium at this point. So you want to plan for that and remember that you can get efficiencies in your project costs elsewhere. We had another question. This one's for Andy. It's from John Soloway. We wanted to know, Andy, if you could talk a little bit about how did your carpenters pick up on the principles of mass timber? This building was built by carpenters, and how did they build skill quickly to do this?
Yeah, like I mentioned, Chrisman does vertical construction. We've done post-tension decks, mid-rise buildings. So the frame itself and the structure was basically the same. I think the biggest part was the details, how the connections go together. Instead of forming and pouring beams and columns, now they're actually setting beams and columns. It was a lot quicker process. But getting these guys to understand that we're going to be driving pins, installing steel brackets, handling it with kid gloves to make sure we don't damage it. Those were what we had to, beat into those guys' heads to get them to understand. Like every project, you start off slow, and as they get their rhythm, stuff moves more productive, moves faster, moves safer. There probably was a little bit of a slowdown at the beginning when you get these truckloads of wooden beams and columns and deck, and you got to start putting it together. That was a little bit of a challenge there, but the guys picked it up good. We had a great leader on the job who really took it and understood it and pushed the job. So
Nice.
It was very successful for us.
That's helpful. And if there's anyone in the call who has resources to train installers, please feel free to drop anything in the chat that you want to share.
That wasn't, we didn't have that when we were.
Not yet. Now we do. So Jennifer Henson Hessick has a question now, and I think this is a good one. George, you might be able to weigh in here as well as Bill. So did you bid the timber partner as a design assist contract, and what challenges did MSU experience purchasing around the non-traditional procurement strategy?
I can, speak to this. Yes, the MassTimber supplier was a design assist contractor for the reasons noted earlier about getting them engaged, in the SD to DD stage of the project to help right size and talk through connection and optimize the timber. So we did that through a design assist RFP bid package. Challenges wise, MSU actually is very forward thinking and open-minded when it comes to onboarding trade partners. They encourage this type of thinking. So it wasn't a big challenge to present this and get it past MSU, so to speak. It's as long as we showed best value and that we were budgeting correctly along the way. There were no issues there. Probably the most challenging issue was, as George mentioned earlier, part of this project was partially funded from the DTMB, and they, from a state level, they're typically not very well versed or usually allow projects to bid out before construction documents are complete. So that's kind of against the grain with when it comes to mass timbers. You don't want to wait that long because then everything becomes reactionary and things become longer in schedule and cost more. So through conversations and collaboration with DTMB, MSU, and everybody else, everybody was on board, given the nature of what we were doing with this project and with MassTimber.
Oh, Sandra, I think you're muted.
Thank you, Bill. I have a question for Kevin, actually, and this is kind of maybe a brief response, but were there any program-related aspects of the design that made MassTimber more challenging? either due, maybe not due to your like newness to it, but really like more objectively, like was there anything especially challenging about this being a mass timber project related to the program of the building?
I think, yes, there was, because it was a lab building that, the program was to have lab learn spaces as opposed to a traditional lecture, one space, lab in another. But this is all brought together, and the ultimate flexibility was desired from the university to be able to reconfigure labs in the future. And that established a bigger than normal bay size for timber at like 41.5 foot by 39 foot or something in those order of magnitude for a lab. It was good size, and dealing with vibration, not so much from a scientific perspective, but from an occupant comfort perspective was a design consideration. And we looked at traditionally CLT deck or CLT panels come in odd numbers of plies, 3, 5, 7, 9, whatever. But we are structurally we only needed a 3-ply, but from a vibration occupant comfort standpoint, we needed more mass in the structure, but we didn't want to pay both cost and space premiums on going to a 5-ply. So Nordique was able to work with us, and we went with a non-traditional 4-ply system for the floor slabs, which gave that kind of added mass to dampen any vibrations from foot traffic and movement around into that. So that was probably the biggest concern. The other part was being in type 3B construction, which at the time didn't allow any combustibles within the exterior envelope. Now in newer codes, they've allowed specifically CLT in exterior walls that are normally non-combustible. So we had what we called an exoskeleton to support the brick and the windows and those kinds of things that kind of wrapped and cocooned the building to keep our primary structure out of the exterior wall. So that was more of a function of the code language and the material type than not necessarily, but it was a learning curve for us because it added some complexity to us.
That's great. Thanks so much, Kevin. There's a question from Jennifer in the chat about the cost per square foot of the project, and I don't remember that offhand, but I know someone on the call does. It's a high cost per square foot, but it's not because of the mass timber, it's because of the program. Did George or Bill remember?
I'd have to get back. It's been a few years removed, but I could find that information. I know typically, just thinking about mass timber in itself, with the structure you're looking at here, from a total all-in package, if you go with a full CLT glulam package, you're roughly in that $60 to $65 a square foot for structure. That's, maybe a little bit more due to some years of, inflation, but it's roughly right around there on the timber structure itself.
George?
And I think the other point that's worth noting too, like where it becomes a little bit hard to do an apples to apples comparison with this building, is that because of the 3B designation, because of what was allowed under 3B in the 2015 Michigan Building Code, if you were to do this building again, that steel exoskeleton would likely not have to exist at this point. So that's, significant cost. I don't know the number. I can't just pick it out of my brain, but that's, significant square foot cost savings that just result because of regulatory change.
Okay, we're going to move toward wrapping up. So George, I'm going to give you the last question. What, in your opinion, if you are approaching a mass timber building, what is the most important thing for you to be thinking about for your first go? If you really want it to be a mass timber building.
If you really want it to be a mass timber building, I'm going to cheat and say there's two things that you really need to think of. One is very process driven, like you've got to have a more integrated process. Like you've got to go into this knowing that you're going to have an integrated process and you're going to have early involvement of your trade partners, regardless of what kind of delivery vehicle that you're using for the project. That's number one. But I think number two is you really have to also have the mindset where you're willing to tunnel through certain barriers or certain obstacles that might get thrown up through the process. And I can, use an example on campus where cost uncertainty was a really big issue on a project that was trying to be done as a mass timber project on campus. And some numbers were thrown around early in the process, and we took a big step back from that point rather than really buckling down and saying, okay, let's take a hard look at those numbers and really understand where those are coming from and what that means. So you really, if this is what you want to do, you've just got to have that mindset that you're going to move over, around, and through obstacles that may come up.
Great, thanks for that, George. Okay, it's time to wrap up. A few key takeaways. 1, MassTimber is awesome. 2, it is not rocket science, but there's a learning curve, but there's resources out there for you. And the key to your success really is collaborating early and often and continuously throughout the project. If you're looking for more information or to plug into our MassTimber community, contact me, Sandra Lupian at MassTimber at MSU, and we'll get you plugged in. But I want to first thank our panelists, George Berghorn, Kevin Marshall, Bill Bofeisel, and Andy Reese for sharing your expertise and experiences about the STEM teaching and learning facility. And thank everyone who hung out with us past the top of the hour as well. And now I'll hand back to Kayla to close us out.
Yeah, thanks, Sandra. And again, I'll extend a huge thank you to our panelists here today for sharing your expertise and diving a little deeper into this project. I know I want to go on a tour of this building. I have not been yet, so I also encourage everyone on the call to try to get out there if you can. The last thing I'll say is please keep an eye out for the registration links and webinar information for the future MassTimber sessions in this series. You can sign up at our newsletter. There will be lots of links shared in the follow-up email, so I won't try to rush to get it in the chat right this moment. But the last reminder is that this is recorded and it will be available to you. So thank you, everyone. I hope you have a fantastic rest of your day.